on this video, I'm going to go over these last three videos I'll be going over reproductive system, but the first one I'll do is the male reproductive system. Okay, so approximately 77.4 billion people live on this earth. This is an incredible number, considering that the reproductive system is the only system in our body that is not vital for us to live. It does affect other systems, however. We're going to also look to see how various reproductive organs secrete hormones that play major roles in maintaining normal sexual function, and then allow those gametes to come together and form a new human being. Some of the components of the reproductive system. The gonads have reproductive organs that produce gametes and hormones. Ducts that receive and transport these gametes. Accessory glands and organs that secrete fluids into the reproductive system ducts. And perennial structures that are collectively known as external genitalia. Okay, so basically we have gonads, we have ducts, we have glands that ensure that the male and female gametes will come together so they can produce another human being. Okay, so let's start off with the male, shall we? All right. Okay, so let me show you some of the main structures that are part of the male reproductive system. We have ducts, like the ejaculatory duct, our membranous urethra, spongy urethra, ductus deferens, epididymis, with gonads, which are the testes, and then we have external genitalia, which are the penis and the scrotum. We also have some accessory glands like the seminal gland, the prostate, and the vulvourethral gland. Okay, so here we have a model of the male. We'll start off with the sperm first. Okay, so this is a sperm here. Here you see we have the head, this part right here, which is called the neck. Then here we have the midpiece, and finally we have the tail. Okay. And this sperm gets activated by fructose that is produced by the seminal vesicles. You see these little red things in here? There's a bunch of mitochondria in there that pick up sugar and convert it into energy. Okay. And then that energy will allow the movement of that tail. So that tail will be like a fish. Yeah, it'll be moving that tail, even crawling at times when it gets into the female vagina, to the cervix, and eventually to the uterus, up to the fallopian tubes to meet that to meet that egg. Okay. This part up here is called the acrosome, and that acrosome is going to have enzymes within it that are going to help dissolve that corona radiata around the egg of the female and allow this nucleus into the egg or the mature ovum. Then the nucleus, of course, will dissolve and the chromosomes will come out, and then the chromosomes of each of the nuclei, and then they're going to exchange information, okay, giving the child 50-50, mom and dad. That's it. Okay, so where are the sperm produced? The sperm are going to be produced inside the testes. The testes are going to have these ducts inside there. It's called seminiferous tubules. Okay, I'll show you. Okay, so here is a little laminated chart of the male reproductive system. Okay. Look down here, you can see this spermatozoa. There's a sperm. There's the head, the neck, the midpiece, and the tail. Now these sperm are going to be located in these tubes called seminiferous tubules. The seminiferous tubules are very long, about a half a mile long. And the sperm, you can see this is a cross section of a seminiferous tubule, half a mile long in each testes, okay? So a mile in both. So you can see all the tails right there. Okay, this is an actual histological diagram of the seminiferous tubule. And here you can see the sperm being produced from outer to inner. Outer to inner. And I'm going to show you a little diagram of the sperm, how they're produced from outer to inner. So here's the first stage of sperm, and this is the last stage in the center, or the lumen of the seminiferous tubule. Okay, so on the outer part of the diagram I just showed you of the seminiferous tubule, here you have the first stage of the sperm called the spermatogonium. Okay, and the spermatogonium will eventually become a primary spermatocyte. Then that primary spermatocyte will divide into 2 secondary spermatocytes. Then the secondary spermatocytes will further divide. Each one will divide into 2 to 4 spermatids. And eventually the spermatids will become spermatozoa, and those are the ones that you saw in the central lumen, or in the lumen of the seminiferous tubule. Okay. So spermatids and spermatogonia, primary spermatocytes, secondary spermatocytes, spermatids, and spermatozoa. One last interesting fact about the sperm, or spermatogenesis, or the production of sperm, is that the process of spermatogenesis begins at puberty, and it continues until relatively late in life, until past the age of 70. The complete process of spermatogenesis, of producing the sperm, it takes about 64 days. Okay, so I think what we'll do now is just go over this model of the male. Inside the testes, we have seminiferous tubules, and after the sperm is produced via spermiogenesis in the seminiferous tubules, the sperm will go to an area called the reed testes. The reed testes, which is going to connect the seminiferous tubules inside the testes to this structure called the epididymis. And the epididymis is kind of like a college for sperm. It's where the sperm ends up maturing. Okay, easy way to memorize that. And then from the epididymis, the sperm will go up to this structure in here called the spermatic cord. The spermatic cord is going to be made up of the vas deferens, the testicular artery and vein, and the dartos muscle, which elevates the testes to keep the sperm warm if it's cold outside, or if it's really hot, makes the testes go further away from the body. Okay, so the sperm is going to go from the seminiferous tubules to the reed testes, to the efferent ductules, to the epididymis, to the vas deferens. And the vas deferens, let's see, the vas deferens is 16 to 18 inches long. Okay, so here you can see the spermatic cord with the vas deferens inside. You can't really see it, but okay, going up like that. And then here you see the vas deferens going like that. There's the vas deferens there. And the vas deferens is going to end here at this structure called the ampulla vas deferens. Okay? And the sperm waits there. Okay, so let me show you another model. So here we have the testes, with inside being the seminiferous tubules, which produce sperm, go to the reed testes, go to the efferent ductules, then to the epididymis, to the vas deferens or ductus deferens, and it ends here at the ampulla vas deferens. Okay, so once the sperm goes from the vas deferens or ductus deferens to the ampulla vas deferens, the sperm waits here in the ampulla vas deferens, much like a horse waits a stable before it takes off into a race. Okay? And then it waits for the structure here called the seminal vesicle. The seminal vesicle is going to produce semen. Okay, the semen is going to go into the common ejaculatory duct right here, and then now the sperm that was waiting here in the ampulla vas deferens will now be mobilized with the semen that's inside the ejaculatory duct. Now let's talk about a couple of things about semen here. A typical ejaculation releases 2 to 5 milliliters of semen. The semen is going to contain sperm. The normal sperm count ranges from 20 million to 100 million sperm per milliliter of semen. At least 60% of the sperm in the sample appear normal and will be actively swimming. Then you have the seminal fluid inside the semen. The seminal fluid is the liquid component of semen. It's a mixture of glandular secretions with a distinct ionic and nutrient composition. A typical sample of seminal fluid contains the combined secretions of the seminal glands, 60%, the prostate, 30%, the nurse cells and epididymis, 5%, and the bulbourethral glands, less than 5%. And a normally low volume may indicate problems with the prostate or seminal glands. In particular, the secretions of the seminal glands contains Number one, a higher concentration of fructose, which is easily metabolized by the sperm. Number two, prostaglandins, which can stimulate smooth muscle contractions along the male and female reproductive tracts. And three, fibrinogen, which forms a temporary semen clot within the vagina. The glandular fluid the seminal glands produce generally has the same osmotic concentration as that of blood plasma. But the compositions of the two fluids are quite different. The secretions of the seminal glands are slightly alkaline, helping to neutralize acids in the secretions of the prostate and within the vagina. And then the third thing that the semen has are enzymes, and several important enzymes are in seminal fluid, including one, a protease that may help dissolve mucus in the vagina, and two, seminal plasmin, a protein with antibiotic properties that may help prevent urinary tract infections in males. And number three, a prostatic enzyme that converts fibrinogen to fibrin, coagulating the semen within a few minutes after ejaculation. And four, finally, fibrinolysin, which liquefies the clotted semen after 15 to 30 minutes. So those are the three components of semen. We have sperm, we have seminal fluid, and we have enzymes. So most importantly, that semen that's produced by the seminal vesicle will activate the tail, will activate the sperm, specifically the tail part, so it can just start moving, and indiscriminately it's just going to move forward. After the sperm has gone through the common ejaculatory duct, then it's going to go in here to the prostatic urethra. The male urethra is divided into three parts, not equal parts, but divided into three sections. We have the prostatic urethra, which is surrounded by the prostate, the membranous urethra surrounded by the urogenital diaphragm, and the penile urethra, which is surrounded by or spongy urethra is another name, surrounded by the penis here. There's a muscle right here. This muscle is called the urogenital diaphragm. It's also referred to as the external urethral sphincter. Okay, and that is going to be voluntary. The internal urethral sphincter, you can't see it here, but on top of the prostate there's some internal urethral sphincters. Actually, we can say right here, this two little bumps right here. That's the internal urethral sphincter, and that's going to be involuntary control of the muscles that prevent the urine from going from the bladder, this is a urinary bladder, to the urethra and then out. So involuntary control, internal urethral sphincter and external urethral sphincter. So that part of the external urethral sphincter of the urethra that it surrounds is called the membranous urethra. So we have prostatic urethra, membranous urethra, and then finally we're going to have inside here, we're going to have the penile urethra. Starts right after the muscle, and it goes along the whole length of the penis, and it stops right here. Then at the end here, this is like a little swelling of the urethra. That's called a navicular fossa. By the way, that's the only one that I got wrong on the test, and I knew I was going to get it wrong. I was in the Navy, and the irony of me forgetting that is just incredible. The only one I got wrong on the test. Then finally here you have the little hole that's coming out. That little hole at the end of the gland's penis. That's called the external urethral orifice. Okay? So what else should we go over? Let's keep on going over some glands. We went over the urethra. So let's go over the prostate. Prostate, this almond-shaped side structure. So the prostate. Okay, so the prostate is a small, muscular, rounded organ about 4 centimeters or 1.6 inches in diameter. The prostate encircles the proximal portion of the urethra as it leaves the urinary bladder. The glandular tissue of the prostate consists of a cluster of 30 to 50 compound tubulo-alveolar glands. These glands are surrounded by a thick blanket of smooth muscle fibers. The prostate produces prostatic fluid, a solution that makes up about 1/4 of the volume of semen. The slightly acidic fluid is rich in enzymes such as acid phosphatase and analase that prevent sperm coagulation in the vagina. Prostatic inflammation or prostatitis can occur in males at any age, but it most commonly afflicts older men, prostatitis can result from bacterial infections, but also occurs without pathogens. Signs and symptoms can resemble those of prostate cancer. Men with prostatitis may have pain in the lower back, perineum, or rectum. In some cases, the symptoms are accompanied by painful urination and mucus discharge from the external urethral orifice. Antibiotics are effective in treating most cases caused by bacterial infection. So basically, what you want to know about the prostate, that prostate helps clean the urethra to prevent any kind of infection, and it has about 25% of the production of semen is produced by the prostate. Okay, so let's go over, I think we went over we need one more gland, okay, which is going to be the Cowper's gland, or bulbar urethra gland. Let's see what it looks like. Recording. Okay, so here, it's the only model I really have that shows it, but this is the Cowper's gland here, and the bulbar urethra gland, okay? Okay, so let's read a little bit of what it says here for the Cowper's gland.
Bulbar urethral glands.
The bulbar urethral glands, or Cowper's glands, are compound tubular mucus glands located at the base of the penis. These glands are round with diameters nearly 10 millimeters, less than half an inch. The duct of each gland travels alongside the spongy urethra. The bulbar urethral glands secrete thick alkaline mucus. The secretion helps neutralize any urinary acids that may remain in the urethra, and it lubricates the tip of the penis. So all I got really left to do is just talk about the components of the penis itself. We have the corpus cavernosum and the corpus spongiosum. Corpora meaning a pair, corpus meaning singular. So the corpus cavernosum are these look like little caves here, and that has erectile tissue. Okay. And the corpus cavernosum is paired. There's two of them. Okay. You can see it's like a double barrel shotgun. And on the bottom here we have the corpus spongiosum, which surrounds the spongy urethra or the penile urethra. Okay, then finally here, the corpus spongiosum becomes the gland's penis. Okay, so this guy here is circumcised. There's no skin over the gland's penis. Okay. And then finally out here, you're going to have the external urethral orifice. Okay. One thing about this is the corpus spongiosum becomes the gland's penis. It's the same kind of erectile tissue. Okay, so that's pretty much it, the male reproductive system.
Recap: male reproductive system.
The sperm is produced inside the seminiferous tubules within the testes, about 1 million sperm a day. Okay, each testes has about a half mile long of seminiferous tubule producing these sperm. The sperm eventually goes to the root testes, to the afferent ductules, eventually to the epididymis, where the sperm is stored and matures. Then the sperm is going to go from the epididymis up to the vas deferens, and then wait at the ampulla vas deferens. It's going to wait for the seminal vesicles to produce seminal fluid. Most of the semen that's produced is produced within the seminal vesicle, which produces fructose, which activates the tail of the sperm, and then the sperm will be highly active, going to the prostatic urethra, which is surrounded by the prostate, which the prostate produces about 25% of the semen. It helps clot all the sperm inside the female vagina, and then the sperm will go from the prostatic urethra to the membranous urethra, where right around that area you have the Cowper's gland also producing a kind of a thick mucus that helps lubricate the tip of the penis and also helps fight the infection of the urine in the urethra. Then the sperm will go from the membranous urethra to the penile urethra to the penis. Okay. Penis being made up of the two corpora cavernosa and one corpus spongiosum. Corpus spongiosum becomes the gland's penis, and the sperm goes from the penile urethra to the navicular fossa to the external urethral orifice and eventually out. Okay? That's it. The male. So the bottom line, this whole video could have been done in probably a few seconds. After we said that sperm is produced in the testes, it is ejected, and the female takes care of the rest. That's all we do. Just give her the sperm, and then The female has to do the lion's share of the work, okay, which she should have the lion's share of the say of what to do with her body with the doctor to say. Okay. All right, so that's pretty much it for the male. The next video I'll do is the female. Hope you like this video. Make sure to like and subscribe, and I will check you out for the female reproductive system. Take care. Goodbye.